thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, and thank you for tuning in to week 19 of the Oxygen Concentrator Talk brought to you by the Oxygen Alliance. You're with me today, Mwali Lungu, and I'm very pleased to be hosting the call from Lilongwe, Malawi. Joining me on the call today are our usual technicians from OpenO2 and Sunrise. So we have Paulina Mohosho joining us from Johannesburg, South Africa. We have Cynthia Chukomoni, Francis Sambani, and Teto Sinjani joining us from Lilongwe, Malawi. So we also have a new technician on the panel today, Efa Solomoni. She is one of the interns on the OpenO2 mobile team, so she's joining us for the call today. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. So here we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So we always encourage you to send questions to us in advance so that our technicians can have a look at them and then they can help you out with the right solutions. So just a reminder to all of us that we encourage you to keep your microphones muted and your videos turned off just to conserve the bandwidth for everyone. All right, so before we jump onto our questions, just like we have been doing for the past two calls, I would like to just get a quick update and hear from anyone on the call of what we have been working on during the week and some updates from you guys. So I will leave the floor open and then whoever has an update can just come off mute and then you can share with us what you've been working on. Go ahead, Mosofa.
Hello, everyone. My name is Masopa Mujaji. I work for Sunrise South Africa as a technician. In the past weeks, I have received a oxygen concentrator, Oxyflow 5 M50 to be specific, with a reported problem of no flow. And then as a procedure, I ran the unit for incoming evaluation to confirm the reported problem. And then I confirmed the problem. Then I replaced the compressor. It was faulty, and the pneumatic valve. And then I put back the machine. I switched it on, and then it gave me an error of HO8, which is an error on the screen, which is an error for a low pressure. And then it started alarming. So I thought it's the OSD on the PC board. Then I took another new PC board. Then I replaced the PC board and then put the machine back. And then I turned it on, and then it gave me the same problem, the low pressure. Then I also did a refill on the sieve beds, and then put a new pressure regulating valve. And then the machine still gave me a problem. So I put the machine aside for a couple of days, trying to figure out what can be the problem. Then on those few days, then I thought I should maybe check the piping. So I noticed there were insects on the check valve when I did the last check, and then I managed to clean the check valve. And then while I was cleaning, I looked for another one, and then I found a new one. Then I changed the check valve, which is a one-way valve. And then I found my pressure. So that's the challenge I've got through. Thank you, everyone.
Thank you very much, Mustafa, for that update. So it's indeed a common thing. So we have also come across that a couple of times where you get
So Maui, I think we
can you hear me now?
yes.
Yes.
Okay, great. Sorry about that. Yeah, so I was just pointing out that this is a common issue and that we have a question that someone asked regards to this issue. So we are also going to talk a bit more about that question. So thank you very much, Masofa, for that update. So moving on to our questions now. So our first question today says, as biomedical engineers, technicians, and users, how can we manage the risk and challenges of both home and hospital oxygen therapy devices? So I will ask Paulina to answer this question.
Thank you, Mabi. Oxygen therapy delivers huge benefits in terms of supporting patients' health. Though oxygen therapy is important in saving lives, it comes with everyday challenges and risks. These include fire and electric hazards. The common risks and precautions are as follows. The first and most serious of this is fire. Both cylinders and concentrators involve the use of concentrated oxygen. Oxygen-rich environments increase combustion, meaning that fires that start more easily, it means that fires that start more easily and burn more intensely. With the right environment, even substances that do not usually burn can be set ablaze. So for home oxygen users, this brings about some real risks. Cigarettes, gas cookers, heaters, candles, and even electrical sparks can all cause serious fires if not managed correctly. At the same time, using petroleum-based lubricants can also lead to fire. The above-mentioned risks can be avoided by doing the following things. You would need to check cannula tubing for leakages. If there are any leakages that you find on your tubings, your cannulas, you need to report that to your biomedical engineer or the technician for a service. You need to avoid oil-based lubricants. This can increase the risk of fires. Patients should avoid having flammable materials when using oxygen. Avoid smoking and open flames. Never smoke near where the oxygen therapy is being administered. Store oxygen safely. For example, hospital cylinders should never be exposed to open flames. Another thing that you would need to do is to turn off oxygen concentrators and cylinders when they are not in use. When you leave a concentrator or cylinder running when not connected to a patient, you increase the concentration of oxygen in the air, which then increases the risk of fire. So another hazard that you will come across is the electrical hazards. So oxygen concentrators, they rely on electricity or battery packs for operation. And as with any other electronic equipment, these come with their own safety risks. When you have some loose connections within the oxygen concentrator or on power supply outlets, you risk causing electrical sparks, which can cause combustions in oxygen-rich environments. Oxygen cylinders do not use electricity, and therefore they do not pose the same risk as the oxygen concentrators. So to avoid these electrical issues, you are advised to routinely assess the equipment and ensure an electrical fault-free environment to avoid such occurrences. Thank you, Modi.
Thank you very much, Paulina, for that explanation. I hope that was clear for everyone. But if we have some questions or comments, we are free to ask or add on to the explanation that she has just given us. All right, so no questions there. So moving on with our questions. So our next question says, I am a biomedical technician and there is a DeVille-based 525 concentrator that I have to service. When I switch on this concentrator, it runs for a few seconds, then the compressor relief valve pops. It stops after a few seconds and then pops again. What might be the problem and how can I solve this? So I will ask Efa to answer this question.
Thank you, Mawilungu. An oxygen concentrator takes in air from the surrounding and purifies the air using the compressor swing absorption process to produce oxygen. The compressor inside the concentrator increases the pressure of the air taken from the surrounding by reducing the volume that the air is occupying, and this law is known as Boyle's law. The pressurized air then goes to the sieve beds where nitrogen is absorbed by the zeolite due to the high pressure leading to the reduction of the nitrogen in the air coming out from the sieve bed, and this results in the increase of oxygen concentration. Depending on the concentrator model, either a rotary or solenoid valve is used to allow the feeding and paging of the sieve bed simultaneously. Compressors used in oxygen concentrators have a relief valve that pops or opens to allow the air to escape when there is pressure buildup in the system. This is put in place as a safety feature to avoid damaging the compressor or even injuring the person. A common source of pressure buildup in a concentrator is due to blockage either in the sieve bed or further upstream. So to solve this problem, remove the covers of your concentrator, then disconnect the tubing on the outlet of one sieve bed. Then switch on the concentrator, and then you have to listen attentively if the pressure relief valve will pop up again. If it doesn't, reconnect the tubing to the sieve bed and disconnect the tubing on the outlet of the other bed. Listen carefully again if you can hear the relief valve popping again. If the relief valve stops, then the sieve bed you have disconnected is the one blocking the air. Remove the old zeolite in the beds and refill the sieve beds with new zeolite. So even though you have one bed blocking the compressed air, both of the sieve beds have to be refilled or changed because having old zeolite in one bed and new zeolite in the other will contaminate the sieve bed with the new zeolite. So to be safe, you have to change both of the sieve beds. Thank you, Maui.
Thank you very much, Efa, for that explanation. I hope that was very clear for all of us. But just in case we have some questions or some additional comments, we are free to add on to the explanation she has just given us. So if we don't have any questions, moving on to our next question. So our next question says, I am a biomedical technician working at a certain private hospital. Currently, we have concentrators in our workshop whose flow meters are malfunctioning, and we do not have spare flow meters for this particular concentrator model. Our oxygen concentrator flow meters for different concentrator models with the same flow rate interchangeable, so that we can replace the flow meters with the ones we have for the different models. So, Mteto, if you would please take this one up.
All right. Thank you, Maui. So flow meters control the amount of oxygen released to a patient, to the patient's outlet. And different flow meters come with different flow rates. Most of the concentrators we see around come with the maximum of 5 liters per minute, 8 liters per minute, or even 10 liters per minute. So to answer this question, the following are the factors you need to consider when you want to replace a flow meter picked from another oxygen concentrator. So you need to look at the form factor of the flow meter. So this is basically the physical look of the flow meter. It needs to match the size of the original flow meter. This is in terms of width, height, and the position where the inlet and the outlet port is. So if you could go to the next slide. So another thing to look into is pressure at which the flow meter is calibrated. Otherwise, you cannot, you can actually get false readings. So like most of the flow meters we see, some like the one on the graphics on the right side, that was calibrated at 20 psi. So you need to make sure that if you are replacing the flow meter, it also has to be calibrated at 20 psi. And the one on the left is calibrated at like 50 psi, which is 350 pascal. So these are the things you need to look into when you want to change the flow meter. Another thing to look into is the maximum flow reading of the flow meter. So it's not actually recommended to place a 10 liter per minute flow meter on a 5 liter per minute oxygen concentrator, because this can lead to low oxygen purity, as the concentrator is designed for a maximum of 5 liters per minute. So having the concentrator like going above 5 liters per minute will actually kill the performance of the oxygen concentrator. So same as vice versa, a 5 liter per minute flow meter cannot be placed on a 10 liter per minute concentrator. Why? Because the oxygen concentrator will not be able to perform to its fullest. So you need to make sure that you put in a 10 liter per minute flow meter for a 10 liter model. Otherwise, you won't get the whole performance of that particular oxygen concentrator. Thank you, Maui.
Thank you very much, Mteto, for that explanation. I hope that was clear to all of us. But if we have some further questions or comments, we can add on to the explanation that he has just given us. So we have a poll at the end of this question. So Mteto, if you would please launch the poll.
Yeah, sure. And I think while I'm launching the poll, maybe you want to also just check in the chat, because I think I saw a comment or a question. So anyways, so I'm going to launch the first poll. So since time has passed, so people have voted. It's actually 2 yeses and 2 noes. So it's a tie.
Okay, great. Thank you very much, Mteto. So looking at the question in the chat, so this is a question from Michael. And the question says, can a 40 solenoid valve contribute to the triggering of the pressure relief valve on the compressor? So I think this question is related to the question that Effa just answered. So Effa, would you want to answer this question?
Yes, Mario, thank you. Yes, a solenoid valve can lead to triggering of the relief valve in such a way that the way the solenoid valve works, it allows one bed to be feeding whilst the other bed should be paging. So if one valve is unable to close or to open, let's say a paging valve is unable to close, it means that, to open, it will mean that instead of the nitrogen in the sieve bed, which has to be paged out to be released, it will remain in the sieve bed. This will create more pressure in the sieve bed. And as a result, as I have already said in my answer, that if there is pressure build up in the system and if it goes beyond the set point of the relief valve, it will definitely trigger the relief valve of the compressor to open up. I think that answers your question.
Okay, great. Yeah, so Michael, if you have some further questions or comments, okay. So I see I've typed in the chat, so I guess that's clear. All right, so moving on with our questions now. So our next question says, I have a 40 concentrator that I am working on. The flow rate on the flow meter of the oxygen concentrator and that on the oxygen analyzer are not matching. While the oxygen analyzer is reading 3.4 liters per minute, the flow meter bore is floating at 5 liters per minute. I have checked for leakages and no leakages are present. I have checked for the output pressure in the service manual and it says it should be greater than 100 kPa. Currently, the pressure is at 104 kPa. The oxygen purity is also low. What could be the associated problem with this concentrator and how can I solve it? So Cynthia, if you would please take this one.
Thank you, Maui. Okay, so the flow mismatch between the oxygen concentrator flow meter and the oxygen analyzer flow meter could be the result of the low pressure from the compressor. For you to rectify this problem, you have to first check if the compressor is in good working condition by using a pressure gauge attached to the exhaust of the compressor and blocking the relief valve. If you get the maximum output pressure, you can compare it to the maximum pressure of the compressor given by the manufacturer performance chart. If the value is too low compared to the indicated performance chart, it means that the compressor is weak and needs service. After servicing the compressor, check if the flow chart, if the flows match, and if the purity is okay, then you can also replace the zero light in the sieve beds, and then you can check the performance of the sieve beds after replacing the zero light. After servicing the compressor and filling the sieve beds, the performance should be better and the flows should match, as this is the problem that was caused by the underperforming compressor and also clamped zero light in the sieve beds. Thank you.
Thank you very much, Cynthia, for that explanation. I hope that was clear for everyone else. But in case we have some questions or further comments on that, as usual, we are free to add on to the explanation she has just given us. So just a reminder to all of us, especially to those of you who are joining us for the first time, we encourage you to share with us your email address in the chat so that we can add you to our mailing list, so that we should be sending you reminders of the Concentrator Talk call and frequent updates from the Oxygen Alliance. Right, so moving on with our questions. Our next question says, I am a technician working for a medical device distributing company. I have a patient that has an oxyflow machine that alarms and is showing error 1 on the screen immediately after switching it on. What could be the cause of this error? So Paulina, if you would please take this one up.
Thank you, Mobi. Error 1 means that there is a thermistor malfunction. So the Oxyflow 5 has a thermistor wire that is connected to the compressor and the compressor board. The purpose of this thermistor wire is to measure the temperature of the compressor. So when the temperature exceeds the maximum allowable temperature, then the thermistor wire will send the message to the control board and the compressor will shut down and will only resume working after the temperature has decreased. So in most cases, this error is caused by the thermistor wire disconnection from the PC board. So what you would need to do is you will need to open your machine and check if the wire is still intact on the socket on the PC board, on its socket on the PC board, reconnect it if it is disconnected. When doing this, it is important to check the elasticity of the compressor mounting springs. If you can see that the springs are weak, you would need to replace the springs to prevent the compressor from dropping lower than it should and pulling the wire out from the PC board. So if you open the machine and you find that the wire is still connected on the motherboard, then you will need to check between the thermistor wire point and the SMD ceramic capacitor at the back of the PC board. So you would need to use a multimeter, put it on continuity, check if there's continuity there. Then if it is there, if there is none, then you would need to repair the motherboard. So what you would need to do then is to either replace the SMD capacitor, or either change the point of the thermistor wire. Or what you can do, if you don't have those parts, because it's just tiny parts, you can just replace the PC board altogether. Thank you, Mobi.
Thank you very much, Paulina, for that explanation. I hope that was clear enough for everyone. So there was a time where I also came across a similar problem, but then this one was being caused by an overheating compressor. So after some time, the compressor would overheat, and then it would just cut the power. So it took some time to realize that there was an issue with the thermistor. It seems it wasn't disconnecting at the right temperatures, so we had to find another thermostat and replace it. So yeah, that was very helpful information. So if we have some further comments or questions on the answer that Paulina has just given us, you are free to add on to the explanation. If not, we are now going to take a slight diversion from the questions, and we will now jump on to our topic of interest for today. So today we'll be talking about monthly maintenance schedules. So we talked about weekly maintenance schedules in one of our previous talks. So today we'll be talking about the monthly maintenance schedules. So Francis is going to take us through. So over to you, Francis.
Thank you, Maui. So as Maui already pointed out, today we'll be looking at monthly maintenance activities and checklist. So firstly, we should know that all equipment is made up of various parts, and these parts can be moving or non-moving parts. And of these moving and non-moving parts, some parts may be active and others may be passive. So at any time during the life of the equipment, these parts can fail due to wear and tear. So this also applies to software. meaning to say it is very much important to give regular attention to the equipment through planned preventive maintenance, PPM, and corrective maintenance repair. So depending on how well an equipment is looked after, the equipment life can be achieved or can be cut short. Thus, maintenance is crucial for the life of the equipment itself. And if maintenance is not carried out regularly and on time, the equipment life will deteriorate to a state where it is beyond economical repair. So what this means is that the cost of repairing the equipment will be much larger than the cost of replacing it. So yeah, okay. And also, if maintenance does not occur at all, the equipment will grind to a halt. So those are the problems that you may have if you are repairing an equipment less frequently or you don't repair it at all. So we'll look at the potential itself and the life of an equipment with and without maintenance. So next slide. So this is the potential life of an equipment with efficient technical support. So for an equipment that has efficient technical support, you have a short storage time and short installation and commissioning period. Yeah, before the equipment is ready for operation. So you can see on the y-axis you have the percentage output potential, and on the x-axis you have the time. So that is like the period. Yeah. So with an equipment that has efficient technical support, you'll be able to get the full, that is 100% output potential from that equipment. And also what that means is that there will only be a short period when working at a reduced potential, which will be corrected by maintenance and repair. This also means that you have less downtime, and it will be returned to full working potential through maintenance itself as well. So of course, the next time the equipment has a reduced potential, it will reduce the potential much larger because of age itself. So that will also be corrected by maintenance and repair. And if we look at the next slide, we have an example of an equipment without efficient technical support. So this is actually common in around this country anyway. This is common, as in you have a longer storage time and installation and commissioning period before the equipment is ready for operation. And also that means that since the equipment has stayed for a longer time without use or anything, just being stored, you will never get the full output potential from that equipment itself. And the next time you have a problem with that equipment, you get a reduced output from that equipment as well. And since there is no efficient technical support, you have longer periods of equipment downtime, and it won't. When the equipment is returned to service, you won't get the same output as you did before. So overall, you have a reduced lifetime of the equipment with when there's lack of efficient technical support. So moving on, this means to say that if you want to prolong the life of the equipment, we need to inspect, clean, and repair the equipment in a planned way. So we'll look at preventive maintenance, and preventive maintenance work activities differ from equipment to equipment. Some activities that can be done, in this case on the oxygen concentrator now, the activities will be done either on daily basis or on weekly basis, or after every month, so that is monthly basis, or after some 3 months, so that is like quarterly basis, and you can do them like after every 6 months. So as already said, this week we're going to talk more on the monthly maintenance activities on an oxygen concentrator and the checklist itself. So monthly maintenance is like weekly maintenance with a few additional activities, and the activities involve, one is cleaning. So on cleaning, it involves removing the dust and debris from the external and interior parts of the oxygen concentrator itself. So you wipe the outside of the concentrator cabinet with a damp cloth, and a mild detergent. So looking at the things that you can clean, you have the gross particle filter or the cabinet filter. So if the cabinet filter is dirty, you must wash it with soapy water and then listen gently with warm water, and you can gently squeeze the water out of the cabinet filter itself and let it air dry. So you don't have to put it in the sun, just on some shade, and the air will do its job. So that's on how you can clean a gross particle filter, and on how you can clean the humidifier bottle. So the humidifier bottle must be cleaned thoroughly. So you must remove the cover and then rinse the inside of the container with clean water, warm water. So you should also remove the air outlet, the air inlet pipe, and run some warm water through it. So the warm water will help to remove any salts that might have started to accumulate inside the pipe. And if you notice that the outlet pipe is blocked, you can use a sharp needle to clear the airways of the pipe. And then you must refill the humidifier bottle with distilled water after use. So also, just a side note on that is that if you're using distilled water and on a single patient, you can use it for a week. But then if you're using like tap water, you're supposed to change it on daily basis. So this is all on cleaning. And on the second thing that you can do as a monthly check would be visual inspection. So on visual inspection, you just aim at ensuring that all parts that are present all parts are present, and also that they are tightly fitted. So you check if the screws are fitted, and you check if all connectors and tubes are fitted. You also check the number of run hours. So you compare from last month and this month, like how long it has run for. So that's like inspection. You just inspect and see if something is out of order or not. And on the third thing that you must look at is functional checks. So on functional checks, there are actually a couple of things that you can look at, and the first one being the period itself. So the longer the concentrator runs for, the lower the period it gets on the concentrator. So period of an oxygen concentrator must be checked every week in order to avoid giving the patient lower purity oxygen, because the purity can drop at any time due to several other factors as well. So when checking for purity of the oxygen concentrator, make sure that the flow meter is adjusted to the maximum capacity that it was designed for. That means if the flow meter is if the oxygen concentrator is a 5-liter oxygen concentrator, you put the flow meter at 5 liters per minute. Don't test it at 2 liters per minute. If it's a 10-liter oxygen concentrator, you test it at 10 liters per minute. So you must also note the purity level, the oxygen purity that you're getting from that concentrator. So World Health Organization recommends that you are supposed to get 82% or more from an oxygen concentrator, but then we advise you that the purity should be above 85%. At least that's better. So yeah, if you find out that the equipment is underperforming, that means you have to maintain it. So you should keep track of the purity levels each and every time you get the readings. So that's on purity. And moving on, still on the functional checks, the other thing that you can check on is the patient outlet pressure. So for most concentrators, the outlet pressure is set somewhere around 7 psi and 10 psi. But then some models, for example, the AirSelf, you have them set at 20 psi. So you should know for that concentrator model that you're trying to check, you should know what is the output pressure that the manufacturer recommends. So, and then you connect your pressure gauge and then check what pressure you're reading from that concentrator. So, as already said, the flow meters are calibrated at a certain pressure. So if you've ever noticed or come across the flow meter of an AirSafe, especially the 8-liter and 5 and 10-liter models, you'll find that the flow meter is being calibrated at 20 psig. So that means to say, if maybe the output pressure of that concentrator is 15 psi, the flow meter will be giving wrong flow readings. So, for example, you might have the flow meter bore at 10 liters per minute, but you want that doesn't mean you'll be getting 10 liters per minute from that concentrator. So the flow will be affected by pressure. So if you find that the pressure is low or higher, you should readjust it to the recommended pressure. So also, yeah, so that's on the patient outlet pressure. And now you can also monitor the performance of the compressor itself. So the compressor produces a fair amount of noise when the concentrator is running. Normally the noise produced is usually constant. So, and after the compressor is run for a certain period, it will start to produce a loud squeaky sound. When you notice a change in the sound, get the compressor checked. So an easy check for a compressor would be to just connect a pressure gauge to the compressor outlet, and you remove the or you block the relief valve by maybe removing it and placing it and fitting that has no output at all. So you then switch on the compressor and then try to read the maximum flow, the maximum pressure that you're getting from that compressor. And then you can compare that to the maximum output pressure of that compressor, which you find it in the manufacturer's performance chart of that compressor as well. So if you see that it is low, if the pressure reading you're getting from the from the compressor is low, that means the compressor needs to be serviced. So yeah, that's it on how you can monitor the performance of the compressor. And the last thing that you can look at is checking the alarm systems. So you're supposed to observe the sounds of the alarms and the status LEDs. So you have some status LEDs on some concentrators like the Longfian J5. You have the low pressure, high pressure, low oxygen, high oxygen. So those are like the status LEDs. So you're supposed to observe them, and if you see and if it's normal operating, let's say for example the high pressure and low pressure on the Longfian J5 are supposed to be off, and the low pressure is supposed to be off as well. So you're just supposed to notice and observe. And if you see that and a high pressure or low pressure LED is on, that means there's a problem and that needs to be checked. And if the sound alarm is malfunctioning, you can replace with a battery for models that uses a battery. And if we look at the next slide, so I don't think it's visible on your end. Yeah, but then this is like just a maintenance checklist on like a monthly inspection that you can use. So you have a date on the first column, you have a date, and then you have the hours. So the hours you get from the Hobbs meter or the hour meter. And then there are also some things I also can see clearly, but then you have a percentage oxygen concentration. So every time you do a check, you must write down the percentage oxygen concentration. And if the power failure alarm was on or not, you're supposed to record that. If you have replaced the battery or not, you're supposed to do that. And also if you have cleaned the unit, you're supposed to check that. And also if you have replaced the bacterial filter, you're supposed to check that as well. And if there's any other additional information, you can write on the specific cell as well, and your initials. So coming this far, this brings us to the end of our topic of interest today. And thank you for your attention. Over to you, Mao.
Thank you very much, Francis, for that explanation. That was very detailed. I hope we picked up a thing or two from that. So we'll be picking up from here. So we also have quarterly maintenance and then yearly maintenance. So in our upcoming course, we'll also be discussing that. All right, so now to get back to our questions. So our next question says, a certain nurse from our hospital brought a Sylvie oxygen concentrator to our workshop, complaining that the concentrator was not producing air even after switching it on. Any idea what is happening? So Effa, if you would please take this one up.
Once again, thank you, Maui. So when the oxygen concentrator is switched on and everything is connected, you would expect air to be coming out of the patient outlet. So if there is no air coming out, the problem could be there is some sort of blockages in the system. I would advise you to do a blockage test by removing one pipe at a time, starting from the seedbed outlet down to the patient outlet. In addition to that, you should also check the patient outlet fitting. I have noticed that sometimes insects enter through the patient outlet fitting and build a nest, which leads to blockages. This mostly happens when the concentrators stay for a long time without lining. As shown on the slide, on the far left, we have our a sieve concentrator, and then we are pointing at the patient outlet. That's where most of the technicians, we neglect that part when we're doing blockage test. And then on the far right, there's the patient outlet fitting itself. And we are pointing at a part which was literally blocked by the nest from our insects. So I think we should make sure to check out these parts as well when we have some sort of blockages. So if you have observed that this is the cause of the problem in your concentrator as well, you should make sure that you clean everything. And then when you clean them, you put them together and try it out and see if your concentrator is working properly. Also, please, you should make sure that you remember to tighten the parts where you are removing your fitting to make sure that you don't have any blockages. Thank you.
Thank you very much, Efa, for that explanation. So this is a question that I was referring to at the beginning. So Masofa gave us an update on the issues that he had, and it was something similar to this. The only difference is this was at the patient's outlet spot, but Masofa's situation, it was an issue with the one-way valve. So these things do happen. There are some insects that don't take time. As long as they see an opening somewhere, they get in there and then they build a nest, and that just messes up the machine. So always be sure to be thorough when checking for these blockages. All right, so moving on with our questions. Oh, before we move on, we have another poll at the end of this question. So Tato, if you would please launch that poll.
Yeah, sure. And I see we're running out of time. So anyways, I'm going to launch the last poll actually. So have you ever found a blocked patient's outlet before? So give it some seconds so that people can respond to it. But I just want to point something out, like maybe just trying to speak of some techniques where you can clean this patient's outlet. You can either use maybe a certain wire and then you try to drop some water inside and then poke out the blockage. Or another way, if you have a compressor, it's actually easier when you use compressed air to blow the nest away. So yeah, I've used the compressor before and it works out so well. Yeah. Anyway, so Maui, the votes are in. So it seems like we have one vote for yes, that people have found this outlet blocked, and we have 2 no's. Yeah, thank you.
Thank you very much, Mteto, for the pause. So looking at our time, we are running out of time, but let's just take one more question and then we will end our session. So our last question says, I am a technician working for an oxygen concentrator distributor in South Africa. I have an Oxyflow 5 machine in our workshop that has an overload protection switch problem. I opened the machine to check it inside, but I did not see any visible shorts or burns. I replaced the overload switch, but it still trips. What can be the cause of the constant trip? So Tato, if you would please take this one up.
All right. Thank you, Maui. So the overload protector switch is a small switch or button that is found on the back or at the back of the aux flow 5 machine. Its function is to actually protect the internal electrical components against a running over current or even voltage as well that can cause overheating and damage. So there are several things that you need to look into to find the cause of the problem. So the first step we would take is to actually do a visual check on the wires and the components. If there are no visible faults, like in your case. So another step to take is just to set your multimeter into continuity mode, and then you conduct a test on the power cable and the compressor wires. So replace a part or fix any fault if you find them. In some cases, a compressor might have an internal fault, like overcurrent draw or insufficient torque, which causes the overload protector switch to trip. To see if this might be the cause, disconnect the compressor from the motherboard and switch on the machine. So if it does not trip, then you actually need to replace the compressor. Thank you, Maui.
Thank you very much, Mteto, for that explanation. I hope that was clear for everyone. So reaching this far, if we do not have any further questions or comments from the audience, I would like to thank you all for joining us for the call today. Remember that we'll be here again next week, same time, from 2 to 3 p.m. Central African time. And don't forget to also tune into our YouTube channel. So that's where we upload all our previous Concentrator Talk videos. So go there and check them out. And please don't forget to subscribe once you get there. We also have a website, www.oxygenalliance.org. So if you want to learn more about the Oxygen Alliance and all the work that we do, just go onto our website and you will be able to get all the details that you need. So reaching this far, I would like to wish you all a great week, and we'll see you again in our next Concentrator Talk call. Bye, everyone.
Bye.
Bye.
Bye.